Hello, my name is Alan Schacht and I am the Water Quality Technician here at Clackamas River Water. Clackamas River Water, or CRW, is a district located in unincorporated Clackamas County. It serves around 42,000 people with high-quality drinking water. The CRW treatment plant uses what's called direct filtration to treat the raw river water and make it drinkable. Direct filtration is the process of adding chemicals that mix with particles in the raw river water to settle or filter them out. The plant first went online in 1964 with one basin and 2 sand filters and could filter up to 10 million gallons a day, which is equal to 255 standard railroad cars. In 1972, the plant added 1 more basin and 2 more filters and then could produce up to 20 million gallons a day. And in 1992, 2 more filters were added to bring the plant total up to 30 million gallons a day. The first process of the plant is the intake structure. The intake structure has screens that are about the width of a dime and is designed to allow water in and keep debris and other things like fish out of the treatment plant. The intake also has an air blast system that will blow off anything that is attached to the screens. After the water travels through the screens, an underground pipe carries it to the wet well. From the wet well, there are 4 pumps that pump the raw river water up to the treatment plant. The next process in the plant is the flash mixers. There are 2 mixers that mix the 3 chemicals that are added to the raw river water. The 3 chemicals are alum, aluminum chloral hydrate, also known as ACH, and chlorine. The alum and ACH are added to the raw river water to help bind small particles together to be settled or filtered out. The chlorine is added to kill the viruses and bacteria. From the flash mixers, the water runs down a channel to the back of the next part of the process, the contact basins. As the water is traveling across the contact basins, the heavier particles like sand and silt sink to the bottom. The basins also help with the mixing process of the alum and ACH with the small particles to make them into larger particles that can be filtered out later. After the water travels through the basins, another chemical is added at the end called a polymer. The polymer strengthens the particles, which will help during the filtration process. The water then travels to one of the 6 filters. CRW uses what is called mixed media filters to filter the water. Filtration is the process of separating solid matter from a liquid, in this case, water. Each of the 6 filters has 18 inches of anthracite coal, followed by 9 inches of sand, followed by 3 inches of garnet sand, which is heavier than regular sand. Below the garnet sand is a layer of gravel that's used to support the filter media, and below that is the underdrain system that collects the filtered water. As the water and the particles travel through the sand, they are collected on top and throughout the different layers of the filter. Each filter can run for an average of 16 hours before it gets plugged up and will need a backwash to clear out the particles. During the backwash process, the raw water valve closes and the water continues to filter through the sand. When the water level reaches the top of the sand, the filtered water valve closes and the backwash valve opens. The backwash pump then comes on, pushing clean water through the underdrain in a reverse flow and through the sand, dislodging anything that is stuck in or on the sand. Spray bars on the top of the filter spray water in a circular pattern to help break up any of the particles. The backwash pumps use about 45,000 gallons of clean water to flush the filters. This process lasts for about 15 minutes. After the backwash pumps shut off, treated raw water is applied back to the top of the filters. That water is then filtered to waste to remove any small particles that were not removed during the backwash process. The filter to waste process lasts for about 15 minutes. The backwash and filtered to waste water then goes to the settling ponds where the solids settle out and the clean water returns back to the river. After the water travels through the filters, another dose of chlorine is added and an additional chemical called soda ash is also added to the water. Soda ash is added because it forms a barrier in household pipes to help keep lead and copper from getting into the water. The water then gets sent to the clear well. Underneath my feet is the 1.3 million gallon clear well, which holds the finished water before it goes to the reservoirs and the distribution system. The clear well also gives the chlorine time to kill the rest of the bacteria before it is pumped to the reservoirs using one of the 5 high-lift finished water pumps. In the treatment plant, all the pipes are color-coded. Orange represents raw water, blue represents finished water and backwash water, and brown represents drain water. The computer system, also called the SCADA system, which stands for Supervisory Control and Data Acquisition, monitors the process in the entire plant and allows the operators to make any necessary adjustments. It also alerts the operators if there are any alarms in the plant. Reservoirs throughout the system are also monitored to help keep them at the right levels. This is the benchtop lab. This is where the operators can analyze the water for many different things, like temperature, chlorine residual, and turbidity, which is the clarity of the water. Samples are taken at least every 4 hours to make sure the processes are performing well. This is the main lab. In here we analyze more complex samples. We collect coliform bacteria samples in our water system and report them to the state. Coliform is a bacteria that is naturally present in the environment but should not be found in the finished water. Another sample we analyze for is harmful algae blooms. Although most algae is harmless, there are some types that can produce toxins that could be dangerous to humans, animals, and fish. We can take a sample and this machine can tell us if there are toxins from the algae in the water. In our mini lab, we have a machine called a flow cam. This machine analyzes a small amount of river water to see what type of algae, if any, are present. These samples are collected in the watershed and brought here to be analyzed. It gives the operators an idea of what's coming down the river.